For most of history, flight was an act of faith. Early pilots trusted wood, fabric, wire, and engines that had no obligation to survive the journey. Mechanical failure was expected. Survival depended as much on luck as skill. Aviation did not become practical because airplanes improved. It became practical because engines did. And few companies shaped that reality more quietly than Pratt Whitney. From the beginning, Pratt Whitney was not interested in spectacle. It did not exist to impress the public or chase headlines. It existed to solve a problem that could not be negotiated. Failure in the air is not an option. In the early 20th century, engines were fragile. Heat destroyed components. Stress caused cracks. Long-duration operation revealed weaknesses that short tests could not expose. For flight, these limitations were catastrophic. An engine did not need to be powerful. It needed to be trustworthy. That distinction defined everything that followed. Pratt & Whitney emerged from a Connecticut manufacturing culture that valued precision above all else. This was a region shaped by toolmakers, machinists, and industrial engineers who understood that tolerances mattered, that small errors multiplied, that shortcuts revealed themselves over time. Connecticut manufacturing was not about speed. It was about correctness. That mindset carried directly into aviation. When Pratt & Whitney began building aircraft engines, the goal was not innovation for its own sake. The goal was repeatability. Engines that could run not just once, but continuously. Engines that could survive stress without drama. Early designs focused on durability rather than pushing limits. Components were overbuilt. Materials were chosen for stability rather than cost. Heat margins were respected. Engineers assumed worst-case conditions, not best-case scenarios. This philosophy transformed aviation. As Pratt & Whitney engines proved reliable, aircraft became more than experimental machines. They became tools. Tools that could cross distance, carry payloads, and operate on schedules. Reliability created confidence. Confidence created industry. Airlines formed around predictable engines. Militaries planned missions knowing aircraft would return. Aviation shifted from novelty to infrastructure. And infrastructure demands discipline. As aircraft evolved, so did the demands placed on engines. Speeds increased, altitudes climbed, durations extended. Each advance exposed new weaknesses. Pratt & Whitney responded the same way every time, slowly, methodically, without shortcuts. When piston engines reached their limits, the industry turned to jet propulsion. Jets introduced problems on a scale never seen before. Temperatures reached extremes. Rotational speeds became staggering. Tolerances tightened to fractions of millimeters. Jet engines were not just mechanical devices, they were thermal systems, materials experiments, mathematical problems made physical. A single turbine blade failure could cascade into total destruction. Again, Pratt & Whitney refused to chase spectacle. Instead of focusing on peak thrust, engineers focused on consistency. Cooling pathways were refined, advanced alloys were developed, components were tested beyond expected lifespans. Jet engines were designed not just to function, but to age predictably. That distinction matters. Predictable aging allows maintenance. Maintenance allows safety. Safety allows scale. This is why commercial aviation became routine. Passengers today step onto aircraft without fear because decades of engineering work quietly earned that trust. That trust was not built by bold promises. It was built by engineers who assumed everything would eventually go wrong and planned accordingly. Pratt & Whitney engines became known for endurance. Not because they never failed, but because when they did, the reasons were understood. Root causes were identified. Systems were redesigned. Failures became lessons, not mysteries. That culture of accountability is rare. It requires humility. It requires patience. It requires resisting the urge to move on too quickly. Connecticut remained central to this work. Testing facilities, engineering teams, and manufacturing operations reflected the same mindset that had existed for generations. Work was not finished when it functioned. It was finished when it endured. As aviation expanded globally, Pratt Whitney engines powered aircraft that reshaped the world. Long-haul commercial flights, cargo operations, military transports. Aircraft that carried not just passengers, but economies. Yet the engines themselves remained invisible. This invisibility was intentional. The most successful engineering disappears into reliability. The less attention an engine draws to itself, the better it is doing its job. Pilots trust what they rarely need to think about. Passengers trust what they never notice. Modern jet engines are among the most complex machines ever created. Thousands of components operate under intense heat and stress, coordinated with precision for hours at a time. They do so repeatedly across years of service. That level of reliability is not accidental. It is the product of design philosophies that treat failure as unacceptable, not inevitable. When modern challenges emerged, Pratt & Whitney adapted without abandoning its core principles. Environmental regulations, efficiency demands, and noise reduction requirements forced innovation. But innovation remained disciplined. New materials were tested extensively. New designs were validated slowly. Changes were introduced carefully. Progress did not replace philosophy. It refined it. This approach is not glamorous. It does not generate headlines. It does not promise instant breakthroughs. But it produces something far more valuable: trust. Aviation is built on trust between engineers and passengers who will never meet. That trust is upheld every time an engine starts, runs, and shuts down exactly as expected. Pratt & Whitney's contribution to aviation is not a single engine or technology. It is a standard that says engineering must account for time, for wear, for misuse, for reality. That standard is increasingly rare in a world that rewards speed over certainty. Yet aviation cannot afford that trade-off. An engine cannot mostly work. It must work every time. This uncompromising requirement has shaped Pratt & Whitney for more than a century. It has shaped how engines are designed, tested, and maintained. It has shaped the expectations of pilots, airlines, and regulators worldwide. And it has shaped the quiet confidence with which millions of people fly every day. When you sit in an aircraft cabin and feel the steady hum of engines beneath you, you're experiencing the result of thousands of unseen decisions. Decisions made by engineers who valued restraint over risk. Decisions made in places like Connecticut, where manufacturing culture taught that precision is not optional. Pratt & Whitney did not change aviation by redefining what was possible. It changed aviation by redefining what was acceptable. Failure was not acceptable. Uncertainty was not acceptable. Guesswork was not acceptable. Only reliability endured. That is why the company's legacy is not measured in speed records or dramatic breakthroughs. It is measured in flight hours, in safe landings, in routine success. It is measured in the absence of headlines. And in engineering, that absence is often the greatest achievement. Pratt & Whitney's story is a reminder that the most important innovations are not always visible. They live beneath the surface, supporting everything above them. They are felt, not seen. Trusted, not celebrated. And that is exactly how aviation learned to fly without fear.